You know, we've been graphing the quadratic functions to find the solutions to the equations by looking at where the parabola crosses the x-axis, because that's where y is equal to 0. We're just going to spend a little bit of time here on recognizing a graph of a quadratic function and being able to graph that by hand by finding the vertex of the graph and then finding a couple of ordered pairs on either side of that in order to sketch the shape that looks kind of like this or like this. And again, focus again on solving a quadratic equation graphically. But what I'd like to do is I'd like to just graph a few equations on my graphing calculator. So let's graph these three, but more specifically, let's talk about if they open up or they open down. So the first one is 2x squared plus 8x minus 1. And let's just go ahead and hit the graph key. It should have a nice window for me. So, you know, it looks as though the solutions for this quadratic equation, this one would be, let me see, 1, 2, 3. It looks like about a -4. And then it looks like it crosses the x-axis where y is equal to, x is equal to about 0. But in reality, you see this -1 right here? That's the y-intercept for this parabola. So this actually crosses the y-axis about here, so it really crosses the x-axis a little bit to the right side of 0. But would you focus on the fact that this parabola opens upward? Let's put another one in. Let's put in 4x squared minus 6x. And let's hit the graph key. And look at that parabola. It opens upwards as well. The one thing that that parabola does not have is it does not have a number right here. It's got an x squared term, it's got an x term, but no constant. That particular one crosses at 0, 0. When x is 0, y would be 0, because when you put in a 0 in here for x and square it and multiply it by 4, you get nothing. And 6 times 0 is nothing. So nothing minus nothing will give you nothing. So this parabola crosses right there. Again, we're going to focus on, when we graph these by hand, these vertexes, the very bottommost point. But let's put in the third equation that I've got here, and that is a negative x squared minus 4 times x plus 2. And watch this one when it has a -1 in front of the x squared term versus these two both having 2's in front and a 4 in front, so a positive number. Here comes the third parabola, and please notice that it opens downward, and that's got to do with this negative coefficient in front of the x squared term. So we'll check all of these every time, but what I want to do now is I want to try to start graphing these by hand, and one of the simplest ways to do this is to find the vertex of the parabola and then possibly the y-intercept, and then checking with a graphing calculator. Well, the vertex of any quadratic equation is found by taking the opposite of the b value divided by 2 times the a value. So let's look at this one right here. The b value is a -4, so the opposite of a -4 would be a +4. And then 2 times the a value is a -1. So upstairs I'd have a +4, and downstairs I'd have a -2. And this tells me that the x value would be a -2 where the vertex of that parabola exists. So let's go back to this problem. See this parabola right here? At that spot right there, x is a -2, right there. X is a -2, and it looks like y is approximately 1, 2, 3, 4. Let's see, 1, 2, 3, 4, 5, maybe 6. Maybe y is about 6. So when x is a -2 in this equation, when I substitute that in for x, I'm curious if I might get that +6, again, when I substitute that value in for x. So a -2 squared is a +4, but I have this minus sign out in front. -4 times a -2 is a +8. And then I add this 2. So work left to right. Negative 4 plus 8 is 4, and 4 plus 2 is indeed 6. So the ordered pair negative 2 comma 6 is the vertex of this parabola. From there I can go on and find possibly the y-intercept or find some other points. Let's go ahead and do a couple of problems by hand. All right, so let's do them by hand. So my vertex is found by taking the opposite of b and dividing by 2 times a. So my b value in this problem is a negative 4. So the opposite of a negative 4 is 4, and 2 times the coefficient of the x squared term is the a value. So 2 times 1. So here I have 4 divided by 2 is 2. So I know that the center point and the what's called the axis of symmetry for this quadratic is where x is equal to 2. So what I do personally is I go in here into this equation and I put in x is 2, so I have 2 squared, which is 4, minus 4 times 2, which is 8. So we have 4 minus 8 is a negative 4. So when I go to the right 2 and down 4, I know this is the vertex of a parabola that, look at the coefficient in front of the x squared term. Is that parabola going to open up, or is it going to open down? With a positive number in front of the x squared term, it will open up. So what I might do then is I might use a 3 and a 1 for x so that I can get either side of the vertex. So I sometimes will highlight. I know this is the vertex, so now I'm going to find values on either side. So when x is 3, 3 squared is 9, and 4 times 3 is 12, and 9 minus 12 is a negative 3. Check this out. When x is 1 and I square it, and then 4 times 1 is a negative 4, so 1 minus 4 is a negative 3 again. This is because of the symmetry of the parabola, that these two values will be the same when I've chosen two values on either side of the vertex, which is 2. I've chosen a value 1 less and 1 greater. So when I go to graph these ordered pairs, when I go to the right 1 and down 3, that's this ordered pair, and when I go to the right 3 and down 3, that's the next, I'm inclined to now go and use these as well. So I'll go over here, either side. So I'm going to use a 5. Well, actually, you know what? Using a 0 is really simple. So 0 squared minus 4 times 0 is nothing. So the other ordered pair here to the left of this one is 0, 0. So as symmetry goes, when x is 5, or I'm sorry, this should have been a 4. When x is 4, y will be 0 also, because I'll be taking 4 and squaring it, minus 4 times 4. So 16 minus 16 is 0. And I have 5 ordered pairs now that will help me draw a graph of this parabola. And I can see that it goes on, up, up, and up. Remember that if we were speaking about domain of this function, we can use all real numbers in this function, but the range of this function for my output, my y values, are all real numbers, but my y value looks to need to be greater than a negative 4. This y value right here is a negative 4. So y is greater than or equal to a negative 4. So I'll talk about minimums and maximums. This one has a minimum value. Let's graph another one. So let's find the vertex. So that's found by taking the opposite of my b value, dividing by 2 times a. A is a negative 1. So I have a positive 4 upstairs and a negative 2 downstairs, and my vertex for this problem is a negative 2. So I'm going to put the negative 2 way down here. Now be really careful when you substitute a negative 2 in for x. You have the opposite right there of a negative 2 squared minus 4 times a negative 2 minus 3. The opposite of this, which is 4, would be a negative 4. This would be a positive 8. And negative 4 plus 8 is 4. And you take away 3, and you get 1. So the vertex for this problem is to the left 2 and up 1. The two numbers on either side of this negative 2 would be a negative 1 and a negative 3. You know, it's a bit challenging to put these numbers in for x, but here we go. The first one, it's the opposite of, I guess we'll use the negative 3 squared, minus 4 times a negative 3 minus 3. So negative 3 squared is 9, but I want the opposite of that, so that's a negative 9. Then I'm going to add 12, because I have a minus 4 times a minus 3, and then subtract 3. So a negative 9 plus 12 is 3, and 3 minus 3 is 0. So when x is a negative 3, y would equal to 0. That would be true here. When x is a negative 1, y would be equal to 0. So I go to the left 3, and I don't go anywhere in the y direction. And then I go to the left 1, and I don't go anywhere in the y direction. Next, I'm going to try x is 0, because that's easier than x is a negative 4. They'll both give me the same answer. So when you put in a 0 in for x and square it, you get nothing. Minus 4 times 0, and you get nothing. And you subtract 3, and you get a negative 3. So I'll put a negative 3 in both of these spots. So when x is 0, y is a negative 3. And the first ordered pair right here is when x is a negative 4, y is a negative 3. And we have a graph of that parabola that is opening downward. I might try the next one in a minute using the vertex and the y-intercept. We'll pause to let you take a break and come back.